Good morning, everyone. So, for those who joined our webinar just now, welcome back. And who just joined our webinar right now, welcome to our day 3 of Real E&E Engineering Series webinar. I'm Dr. Singh, today's moderator. It is a great honor that we have Dr. Law Yu Chong with us today. Before we start, let me briefly introduce you the background of Dr. Law Yu Chong. Dr. Law Yu Chong is the Program Coordinator of Bachelor of Science in Intelligent Robotics from Faculty of Engineering at Multimedia University. He received his Bachelor of Engineering degree in Electronics Engineering, majoring in Computer, and Master of Engineering Science degree in Microwave Engineering from Multimedia University in 2001 and 2005. He received a PhD degree in microwave engineering at University Tunku Abdul Rahman, Malaysia in 2019. His research interest is include microwave circuits, microwave remote sensing, electromagnetic compatibility, robotics, and embedded system. Without further ado, let us begin today's topic, engineering applications today. IoT mobile robot. I saw Dr. Law is with a model car in front of him. So maybe Dr. Law want to share with us why he is having a model car with him. Is he going to demo to us how to make the model car or the robot car? Will it be very difficult? Can we make it at home? Let us hear what is going to be shared by Dr. Law. Go to you, Dr. Law.
Thank you, Dr. Sid. Yeah, good morning, everyone. So today I'm going to share with you a very simple methods to create an IoT-enabled robots. All right. So basically, this robot is made by some ready-made components. The mechanical structure, basically, you can find it online, right? So you can go to some online shopping site, like for example, Shopee, to find, right? And then the electronics are also commonly available, right? So for now, I will try to show you where you can actually source for this part, all right? Okay, I'm sharing my screen here, all right? So you can actually go to shopee.com, all right? And then after that, perform a search, right? So for example, like an Arduino robot car, right? So you can see that in the uh, online supplier, right? So they offer a number of different types of robotic car or robotic kits that you can use in order to build your car, right? So for example, right, like the first match here, right? So you can just click inside, right? So a basic two-wheel car, it will just cost you about 20 ringgit or less, right? So we can you can basically purchase the parts and after that assemble the car yourself, right? Then at the same times, of course, you will need to have some electronics, right? So in this case, we will need some motor drivers and also the microcontrollers, right? So motor driver, right, which I will also share later, right? Maybe you can try to get a motor driver that looks something like this, okay, which again costs a few ringgit, right? Now, in order for us to make this IoT-enabled robot car, we will need a microcontroller that can enable us to connect to the internet, right? So we will need to have a microcontroller with Wi-Fi capabilities, right? So in our example today, right, so we are going to use a microcontroller called not MCU, right? So basically this is a microcontroller, right, with the Wi-Fi transceiver, right? So it will let us connect to the internet and after that able to send the data to the IoT cloud servers, right? So once again, it is not expensive, right? So it will cost once again around 20 ringgit, okay, for the basic microcontroller, right? The one that we use is ESP8266, so it just costs less than 20 ringgit actually, all right? So you may also need to purchase additional jumper cables, right, and also batteries, lah, all right, for this robot as well, right? So those are also some common items, right? So for the batteries, right, maybe you can just purchase a 9-volt batteries, okay? So jumper wires, okay, just purchase a few of these common jumper wires, okay, that you can find online, okay? So once again, just cost a few ringgits, right? So now I will share with you a video, right, on how actually we can assemble the car from scratch, right? So let's just take a look at this video, right? So of course, this is a time set video, right? So as you can see now, what we are trying to do is we try to assemble the base, and then after that, we try to put on the wheels, right? The free running wheels on the chassis, right? Then after that, we'll try to assemble the DC motors, right? So this is a two-wheel mobile robots, right? So it will be powered by two DC gear motors, all right? So we attach the wheels, right? And after that, we attach the top plate. So the top plate will be the one that will hold all the electronics, okay, including our motor driver and also our microcontroller. Right. So in this video, we are showing you the assembly using an Arduino Uno and also a DC motor driver. But of course, in this IoT robot, right, what we are going to do is we will change the Arduino Uno into the not MCU, right? Because we will need to have the Wi-Fi capability, right, for us to connect to the internet, right? So we will use public IoT servers, okay, called the uh, Google Firebase. Okay, so it is a real-time database. So we will use that database to store our data and also to store the control commands, okay, for this particular robots. Right. All right. So after we make the connections, I mean, after we make the chassis of the robots, okay, so the next thing that we need to do basically will be to make the wirings. Okay, so we will use updated wiring as shown in this particular diagram over here. All right. So as you can see just now in the videos, right, we have mounted these two DC motor on the base of the robots. Then after that, this particular motor driver. All right. So we are not going to use Arduino Uno. So we are going to use this not MCU. Right? So we will connect the not MCU to the motor driver using this kind of wiring. Then at the same time, right, for this robot that I'm going to demo, it is powered by a lithium polymer battery that is 7.4 volt. Right? So this is a rechargeable battery. Right? So of course, if you do not have a rechargeable battery, you can also use the 9-volt batteries that you can purchase in the hardware store or any supermarkets, okay, or hypermarkets. All right. So our robots here, later as you can see, it will also be equipped with two sensors. Okay, one of them is the temperature and humidity sensor, and then another one is the light intensity sensor. Okay, the light dependent register LDR sensor. Right. So I will explain more detail about this in the later part. All right. So how the robot looks like. Okay, after we assemble all these things. Okay, so this is the final products. Right. So we will have the robot chassis. All right. So these are the chassis that you purchase through online. Right. Then after that, you can see that this one, the red one, will be the DC motor driver. Right. And then on the right side, this is our not MCU. So this is the microcontroller that allow us to connect to the internet together, at the same time send control signals to the motors, right, to control the movement of the motors. At the same time, it is also connected to all these sensors, right, to get the reading from the sensors, and after that, send them to the cloud server. All right, yeah. So yeah, the 360 view of the robots in actions, right? So we also put it to the test, right? So basically, we can control it by using an app on the smartphone, right? So this app, it can be created by using some open source softwares and also resources, right? So in this case, we are using the MIT App Inventor, right, which is using the block programming method, okay, to create. So it is quite easy to create, in fact. right? So we can manually control the robot to move forward, backward, rotate left, rotate right, right? At the same time, right, the robot will also keep on sensing the environment and after that send the data to the Firebase server. All right.
Wow.
So
Yeah, Dr. Lo, so I think I saw all the components, everything is very is available in the Shopee that is actually can be get it very easy. And also by if we have the instructions if we have the instruction, then it's actually quite easy for us to assemble it in our own at our home. So I just now as from the video I saw Dr. Lo actually control the robot car using his handphone. And also, just now, Dr. Law did explain to us about they actually are using the MIT apps to create this controlling apps. So maybe Dr. Law can further explain about how actually you are doing these apps and how actually you make this IoT mobile robot can be controlled using our phone. So maybe Dr. Lo can share.
yes, of course. Yeah, so let me share some additional informations, right, on how to build up this robot. All right. So as you can see, this is basically our wiring diagram. All right. So we have the Node MCU connected to the motor driver. Then it is going to drive the two DC motor, right? So obviously in this case here, we need not only the circuits and also the programming on the robot side, but we also need to set up two more things, right? So the first thing will be the mobile applications, right? So we need to develop a mobile applications on our smartphone, right? So that it can send data through internet to an IoT cloud server. So now a cloud server is involved here, right? So meaning that we will also need to set up the cloud server, right, in order for it to receive data from our robots, okay, and also send data or respond to the request from our robot and also from the app, right? So this will be the overall block diagram on how the overall setup looks like, right? So on the left side here, right, what you can see is we will have our mobile app that is running on the smartphone, all right? So we developed this app using the, like I mentioned, MIT App Inventor, right? So it is using block programming, right? Quite easy to learn. Right? So this particular app, it will be able to retrieve the sensor data from the mobile robots, okay, and then shown it on the app screen over here, right? At the same time, it also provide a few control buttons for us to control the movement of the robots, right? So the app, it will basically interact with the IoT cloud server, okay? So data will be sent and received through the internet. So the IoT cloud platform that we are using here is basically a free platform. Okay, it's a free platform offered by Google. Okay, so we are using the Firebase real-time database. All right, in this particular example. All right. So at the same time, we will also need to program the mobile robots so that it is able to connect to the internet and after that interact with this cloud server. Right? So the data that is sent by the sensor will be sent to the cloud server. At the same time, the control signal sent from the app here will also be retrieved by the mobile robots, right, to move. Okay, so either forward, backward, turn left, or turn right, right? So we need a few software over here. Lah. So on the mobile robot side, we need to install this, what we call the Arduino IDE, right? So Arduino IDE, you can download it for free, right? So this one, we go for the Firebase setup, okay? So we go to this URL, firebase.google.com, all right? So you may ask to log in, lah, okay? You may ask log in. So in this case, I'm already logged in, okay, with my account. So we press on get started, right? So from there, you can add a new project. Okay, you can add a new project, and after that, you can enter the project name, right? So for example, in this case, I enter a new project name called IoT Robot Car. All right. Then after that, we will press continue. right? So most of the setting can be left as default, okay? So we just press next, okay? When you said account, okay? Also just a default account, right? Then after that, create a project. So this part here, we will need to wait for some time for it to create the projects, all right? So I just fast forward it, okay? So finishing creating the projects, and after that, we just click on continue, right? So as you can see, this is the project screen, okay, on our IoT robot car, right? Next, we click into this real-time database, right? So as you can see now, right, there's new, so there's no database, so we create a new database, right? So the location, leave it to US, all right? And then after that, just default setting, all right? So there are some things that we need to change lah, okay, when we go inside the Firebase database so that we can use it more easily, okay? So I will show you later. So as you can see now, this is basically the URL of your database, right? So we need to change the rules, okay? To make things simple, right? We will just make the database to be public, right? Publicly accessible, right? So to do this, we will change the rules, and after that, we change the read and write to true. And remember, okay, to click publish, okay? Remember to click publish. All right. If not, the rules will not be safe. All right. So remember to click publish. Right. So you will have a warning here. Okay. So say that it is actually allowed for public access. So it's okay. All right. So now we go back. Right. So basically our database ready. Okay. But of course now there is no data at all. Right. So the next thing is to set up our Arduino IDE. Right. So after we download and install Arduino IDE, so the next thing here is, right, we will need to install some additional boards and library, right? Because the not MCU board, basically it is not uh, supported by default by this Arduino IDE, right? So we need to download a new bots, okay? So we specify this particular URL, okay, so that the bots can be loaded, okay, into the IDE, okay? So you can include this one, okay, this particular URL in the Arduino IDE, all right? Mm. Then next, also in order for us to communicate through Wi-Fi and also internet, we need to install additional libraries, right? So we go to manage libraries, right? So wait for it to obtain the updated list. And after that, we type Firebase at the search bar, right? So we will install a few libraries, right? Like for example, this one, okay? The Firebase Arduino client library for ESP8266 and ESP32, right? And also the other library, the Firebase ESP8266 client, right? So these two libraries will be quite helpful, okay, for us to develop applications related to uh, Firebase database, right? So for us to start programming, okay, the simplest method is basically to refer to the examples. After you install the library, okay, you will be given additional examples, right? So we can go to basically this part here, okay, to start with these simple examples, right? So take note that we are going here, okay, go to authentications, and after that, go to test mode. So this is the mode where we set up the database for public access, okay? So not much authentication setting is required, right? So if you look at the source code, what you need to do is basically to define the Wi-Fi SSID and the password. So this is your own Wi-Fi SSID and password, right? Then after that, you will need to set up the Firebase URL, database URL, right? So this is the one that you see just now, all right, in the video when you set up the Firebase database, all right? So we can start basically developing our code by using this example, okay, from this example here. So this is the code that I'm using. So as you can see, okay, what I do is here, I'm modifying, right, to connect to my SSID and password, all right, and after that, the database URL, okay, IoT robot car, okay, 53 FED, right? So it must be the same as what is shown on your Firebase database, okay? So this is what we need to do, okay, in order for us to make a connections from Arduino to this. Now, the next one is the app, right? So we go to the website, okay, appinventor.mit.edu, all right? You will also, if you are visiting it for the first time, you will be also be asked, okay, to log in with an account, okay? So you can actually log in with your Google account, right? Then after that, create an apps, right? So now I have already have this app, right? So basically the app creation is quite simple, okay? As you can see on the left-hand side here, okay, you can include like various button, images, and labels, right? So for example, all these wordings here, like sensor, light intensities, okay, so they are the labels, right? And then all these button, okay, forward, left, right, stop, and so on, okay, they are buttons. So you can just drag and drop all these button into the user interface, okay, into the user interface. Yeah. Now, obviously, this app will have to connect to the Firebase database, all right? So the App Inventor also give us the ability, okay, to communicate with Firebase database. What we need to do is just drag this one over, okay, then after that, similarly, okay, set up the Firebase URL, okay, the same thing as what we have done earlier, right? The Firebase token, this one we can obtain it from the Firebase settings, okay, from the Firebase settings. Yeah, right? So after we have all these buttons and so on, right? So the programmings, right, is basically block-based, right? So as you can see, if you click to the blocks, so you can define what are all these buttons doing, all right? So for example, like all these button 1, 2, 3, 4, 5, and so on. Okay, so you can see that we are having all these buttons on this side here. Okay, so these are the buttons that we have dragged into our apps. Okay, so once you click on the button, then you can start to define like what happened. Okay, when you click, okay, what will happen when you got focus? When you have a long click, then what should be the behavior? Right. So in this case, we define the behavior when we click the buttons. Right? So in the control of this robot, we are using a very simple method. Okay, we are just using the value 1, 2, 3, 4, and 0. Okay, in order to control the motion of the robot. Right? So when we send a 1 to the database, it means that we want the robot to move forward. Okay, 2 will be going backward. Okay, 3 will be turning left, and then after that 4 turn right, and then 0 will stop the robot. All right. So for different button, basically, they will just send different value to the Firebase database, right? Yeah. So at the same time, we want to retrieve data from the Firebase database as well, right? So in this program, we are using a timer to constantly obtain the data or retrieving the data from the server, all right? So basically, okay, we try to retrieve the temperature, the humidity, and also the light intensity, right? So whenever we get a value from the server, all right, we will display the value to the screens, okay, to the text of the labels, right? So this is how we uh, basically design the app now, okay? So as you can see, okay, app pretty simple, right? Just a few blocks, okay? So that will be the design of the app, all right? So on the Arduino part, okay, we will need to do additional codings, right, in order to control the motor according to these settings, right? So as you can see, this is the main coding part, right? So we have these particular lines here, right, in order to get the control string, okay, from the Firebase database. All right. So it will retrieve from the Firebase, okay, the control data, whether it is 1, 2, 3, 4, or 0, and then store it in the variables of control. Okay, so in the variable of control. Right. So based on the control value, right, we will decide whether the robot should move forward, okay, should move backward, turn left, turn right, and so on. All right. So all these codes that you can see inside here, yeah. So for example, like 1, okay, means that going forward. Okay, when it is 2, it is going backward. When it is 3, it's turn left. 4, okay, turn right. Right, and then finally 0, it means that the robot is going to stop. Right. So at the same time, we need to also define the state of a few more pins. Okay, like as you can see from the, oh, sorry. As you can see from these particular videos here, okay, so we need to define the motor direction and also the motor speed, right? So how this should be set, okay, this one I will maybe explain later, all right? So let us look at the next thing is how actually we choose the board, okay, and after that program the microcontroller, right? So after we install the additional boards, okay, so we need to go to this ESP8266 board here, and after that we need to choose this particular module, all right, the not MCU 1.0 module, okay, and then once you connect your PC to this microcontroller, a new COM port will show up, all right? So make sure that you select the correct COM port, right? So that you can program the controller, right? So after all this is set up, okay, so the next thing is we will load the code, right, to the microcontroller, okay? So we load it by pressing this particular button, right? So the IDE will compile first, and after that, start to load the code, right? So the loading process, it will once again take some time, okay? So you have to wait it until it go until 100%, okay, for it to complete the loading process. You can fast forward a little bit. Okay, so after the loading is complete, right, so it will reset by itself. Okay, so now as you can see, when the robot actually when the microcontroller program start to operate, right, you will find that it start pushing data, right, to the Firebase already. Okay, so as you can see, these are the new data that is sent from the microcontroller to the Firebase database. Okay, to the Firebase database. Then at the same time, we also have this particular field, okay, motion and control. Right? So let's say if we modify directly from this Firebase database using our browser, right, you will see that our robot will actually respond, okay, to this value over here, right? So we can manually change it to some values, right? So say for example, if when I press 1, right, so you can see that the wheels, okay, start moving. So basically, this in this case here, the robot is moving in the forward directions, okay, based on the value that is stored on the online database, right? So if we change to 2, okay, then after that, the wheels once again, okay, it will change directions. It will be moving backward, like in this case. All right. So if you change to 3, then we start to turn left, right? So when we change it to 4, yeah, once again, you will see the wheel change direction. So now it is turning right. Yeah. And then finally, if you change it to 0, right? So you will see that the motor stop, right? So basically, this illustrates that the microcontroller is interacting with the online database. Okay, this Firebase real-time database to obtain the value of control, and after that, control the view accordingly. So this is another example on how actually we use the applications, right? So as I show you just now, okay, on the block, basically when we click on the buttons, okay, we are sending 1, 2, 3, and 4, and also zeros, okay, to the Firebase database. So as you can see, this is how the value changes once you press the button. Okay, when you press stop here, okay, so basically the app will send a 0 to the Firebase, and then after that, the motor will react uh, accordingly. All right. Yeah. So this is basically how we make this IoT enable mobile robots. Yeah. Back to you,
Wow,
Stacy.
there's a lot for me. I'm not Dr. Law, so I'm not the expert in robotics. So when I heard about this Arduino IDE, and then the what is the Note and NCU, is it not NCU? So
Yes,
uh
yes. Yeah.
yeah, and then also the MIT apps, and as well as this Firebase. Wow, that's a lot for me. In this within this 10 or 20 second 20 minutes, I don't think that I can make a IoT mobile robot like you. So if I really interest, because but it's very very interesting, and then I would like to if I want to learn from learn this kind of knowledge, where actually I can go. So is MMU have this kind of degree that teach us about this robotic stuff, and then especially teach me how to make this IoT robot car or not? Dr. Low, you need to unmute yours. Unmute. Yeah.
Yes. Yeah, actually, MMU do offer a number of courses that teach us on how to control all these actuator, how to deal with sensors. All right. Before I show you the course, maybe I just give a brief overview lah, okay, on some of this theory. Okay, just a very brief one, right? So basically, as you can see, we are controlling the motors, right? So in order for the motors to turn in clockwise and counterclockwise direction, what we need to do is basically to uh, change the polarity of the motors, right? So in a very simple manner, what we need to do is basically to reverse the directions of the current flow, right? So uh, by using two switches, okay, basically we can change the direction of current flow. So for example, like when the switch is in these positions, right, the current will flow through the motor like this, okay? So the motor will turn in one directions. When we vary the switch position, then the current flow in the opposite directions and the motor will change directions, right? So of course, in the real control, okay, we are using a motor driver, which consists of transistor, all right? So yeah, we will use a HB circuits, okay? We will look something like this, all right? So uh, by specifying which transistor is turned on, okay, basically we can change the directions of the current flow. So for example, let's say this transistor and this transistor turn on, then what happens is current will flow through the motor in these directions, right? If this transistor and this transistor are turned on, then the current will flow in the opposite directions and the motor will change directions. Then at the same time also, we can use uh, pulses, okay, to control the speed of the motor. Basically, the motor run faster when the voltage applied is higher, and then it will run slower when the voltage applied is lower. Right? So we use this thing called the pulse width modulations to regulate the average voltage that's applied to the motor. Right? So we send out pulses on using Arduino, okay, with different duty cycles. Right? So with that, we will be able to control the speed of the motor. So you can control like how far it will go forward, how far it will turn left and right. All right. So the motor driver that I show you just now, okay, in the circuit diagram, right? Basically, internally, okay, it consists of a block that looks something like this. Okay, it looks quite complicated, isn't it? But don't worry, right? So once you join our program, okay, we will have the subjects that deal with all these theories, right? So you will be able to easily understand, okay, what actually happened inside these motor drivers, okay, and then how actually all these signals control the directions of the motors and also the speed of the motors. Yeah, right. So at the same time, also we have sensors, right, attached to the robots. Like for example, the temperature and humidity sensor, right? So it requires three terminals to be connected. We need to connect the supply, we need to connect the ground, and also that after that, one I/O pins to connect to the microcontroller. All right. So external pull out registers will be necessary lah. However, let's say if you purchase a module, okay, that come with a PCB board, then basically you do not need to worry about all these things. Okay, so they are already included on the board. So all you need to do is just to make the wire connections, the supply, the ground, and also the data, okay, to connect to the MCU. All right. So this sensor will be able to measure for us the temperature and humidity, right? The data sent from the sensor will be digital data, all right? So it will be in a serial pulse train, all right? So once again, don't, if you are using Arduino, life are quite simple, right? This DHT library is also available, okay? So you can download the library and then use the library in order to obtain the sensor reading. Right? Another sensor that we are using here, right, is the analog sensor, okay, the light dependent resistor sensor, right? So basically what happened is this sensor, it changes its resistance value based on the light intensity, right? So higher the ambient light intensity, the lower will be the resistance, right? So what we do is we just connect it, okay, in series with resistors to the ground, and then after that, this analog voltage here, it will tell us the corresponding light intensity. All right. So uh, basically the MCU, okay, the microcontroller will read in this particular uh, values, okay, and after that display it on to, I mean, send the data to the Firebase. All right. Uh, Allow me to also, I think, show you a video on actually how the sensor works. All right. So as you can see here, this is the light intensity readings. Okay. So it's 379 now. Okay. So as you can see, the app also updated with the same data. Okay. Slightly later. Okay. Because the database must be updated first, then only the app will update. Okay. So this is under low light conditions. So once we on the light, you can see that the value go high. Okay, 900 something. So now the app also updated with a new value, okay, of 900 something. So this show the changes on the sensor side. All right. So similarly, we can also try to vary the temperature. Okay, so I'm using a hair dryer, okay, in order to rise up the temperature and also reduce the humidity level. Okay, so as you can see now on the database, all right, the temperature will slowly increase and then the humidity will also be reducing. Okay, so this is also reflected on the app itself. Okay, so we can also implement some additional capabilities. Like for example, instead of just overriding the values, okay, we can also store a series of value, means that we keep the history, all right, we keep track of the changes, okay, of the values in on the Firebase database. Okay, so we can use the push functions instead of just the set value functions. Right? So once you have these push functions, okay, you can see that on the Firebase database, okay, we can implement something like a log, okay, a logging of the sensors value. Yeah, okay, so you can see that all these past humidity and light intensity values, okay, they are all saved inside the database. Okay, so you can use it for future reference or for future uh, analysis. All right. Yeah. All right. So regarding the courses, right? So um, basically, we have a new program, okay, called the Bachelor of Science in Intelligent Robotics, right? So as you can see here, right, we have quite a number of courses that actually deal with all these type of components and also the circuits, right? So for example, like the courses, right, they give us knowledge on robotics and automations. Okay, so we have, for example, like electromagnetics with applications. So just now when we talk about Wi-Fi, wireless communication, all these things, okay, so what are actually all these waves, right? How the wave are transmitted, like what are antennas, how they functions. Okay, so all this will be taught under this particular course. And then of course the robotic course, okay, where you study about the mechanisms, okay, the kinematics and so on. Right? Actuator and sensors, like for example your motors, okay, the sensors that we talk about, all right, the control, okay, so how we perform the feedback control, right, automation, the programming, okay, and also how to construct all these different mobile robots, two wheels, right, or two wheels balancing, okay, or three wheels, four wheels, mechanism wheels, so on and so forth, okay, and also some drone knowledge, all right. So yeah, as you can see, robot also involve the embedded system, means that on the microcontroller and also the circuit side, right? So we have the microcontroller subjects, right? We also have basic electronics, analog electronics, digital design. So these are all equipped with you with the knowledge of like transistors, okay, like the circuit that I showed you just now, the motor driver. So with all this knowledge, we will be able to understand the circuit very well. All right. Also, we touch on IoT and cybersecurity, right? So yeah, we will have advanced programming subjects. Okay, we have IoT system and applications, okay, and cybersecurity and so on. So if you want to make your robot to be even smarter, then we have also courses with artificial intelligence, right? So you can, with this knowledge, you can equip your robot with a camera, right? Say for example, like the ESP32 cam, okay, on these robots, okay, so where you can capture image, right? You even send the image to the Firebase database, right? So you can do things like machine vision, image processing, and then you can uh, implement some machine learning algorithm and AI lah, onto the robots, right? So the program have a very strong linkage to Industrial Revolution 4.0. Yeah.
Thank you, Dr. Law, for the course introduction and then what we actually need to know, what we actually were going to study if we join the program, the intelligence of robotics. But one thing, I think if I taking these courses and then when I graduate, I definitely will make can make the IoT mobile robot car like what you showed just now. But one thing is concern me is if I following these courses after I graduate. So is there any a market or a job that is actually available for these courses? So any local companies or the foreign companies is looking for this kind of talents, and then definitely the most important one is it the pay is good? Yeah. So maybe Dr. Lo can share with us about this.
Yes, very practical questions, right? So this particular course basically is designed to be very practical, right? So it is a 3-year program, and then basically we try to combine all these electronics, robotics, AI, automation, computer programming, right, together. All right. So in the elective, right, you can actually choose to become like more hardware centric or software centric. All right. And then our learning approach is that we will balance theory with hands-on practical skills. Right. So in the first year, right, since they are involved more fundamental theories, right, so most of the subject you will have 60% on the final exam and then 40% coursework. But as you progress to year 2 and or even year 3, you will find that there are more and more hands-on. All right. So some subjects in year 3, okay, they even have we even have up to 5 subjects with 100% coursework. Okay, means that we will equip you with all the hands-on practical skill, right, for you to perform in your job later. All right. So if you look at the some of the survey, okay, you can see that our national policy on Industrial Revolution 4.0 is that the national target, okay, for 2025 is that they want to increase the high-skilled workers workforce from 80% to 35%, right? So what we need now is basically high-skilled workers, okay, in the area of IR 4.0, all right? Yeah. So uh, when you graduate, okay, so these are some of the possible jobs that you can take up, right? So like for example, the robotic system designers or programmers, okay, so where you can design and program the robot controller system, the manipulators and so on, right? You can also become an AI and machine learning developer, an embedded system designer, control automation specialist, field application technologies, okay, PCB designer, production and planning engineers, right? And also industrial 4.0 technologies, right? But of course, it is just not just limited to this, okay? We are just showing you a few possible jobs, right? So regarding the pay, okay, so based on the Malaysia Salary Guide by Perso Kelly, okay, you can see that the pay are actually quite good as well, right? So with 2 to 4 years experience, okay, you expect a salary range between 2 to 6.5K, right? So when you have even more experience, right, like for example, 4 years up to 6 years or even more, okay, you can actually expect a salary range that is close to 10K or even higher, okay, with more years of experience. All right. So there are many companies, okay, that are related to robotics, AI, and also automations. Right. So for example, these are the few companies, okay, over here that involved in the manufacturing or design of the robotics arm, okay, the cobot and also the mobile robots, right, like ABB, Hoka, Yaskawa, okay, these are quite well known, okay, if you look at the factories, okay, many of the industrial robots, okay, are supplied by these companies. Okay, Boston Dynamic. Okay, maybe some of you have watched the videos, right, on their humanoid robots and also their four-legged robots. Okay, which is like very stable intelligence. Okay, so yeah, all these are the companies involved lah. Okay, in robotics. And you can also work in the drone industries. All right. So there are also a number of local drones suppliers, okay, and also solution providers. All right. Uh, Now we have a lot of system integrator as well. Okay, we just listed a few over here. Basically, system integrator means that they are combining the hardware and software, right, from different supplier or manufacturer, okay, to come up with solutions to the industries. All right. So all these system integrators, they also required a lot of knowledge workers, okay, in order for them to come up with the solutions. Okay. Last but not least, okay, those electric and self-driving vehicles, okay, are also related, right, to these particular programs. Okay. So I think that's all for me. Any other questions?
Oh, that's a very great sharing from Dr. Law about his IoT mobile car, robot car, as well as about the graduate undergraduate degrees, which is the Bachelor of Science in Intelligent Robotics. So I think not only me, the audience who are actually watching the webinar with us will get to know slightly a bit how to make the robot car. Of course, the knowledge that we actually need to acquire when we want to implement this IoT mobile robot car, and also the introductions by the Dr. Law on the Bachelor of Science in Intelligence Robotics that offer in MMU. So if the audience want to know more about the Bachelor of Science in Intelligent Robotics, so please go to MMU website and make an appointment with us. Uh, we almost come to the end of this webinar, and you can find the attendance form in our Facebook message box or the YouTube Live message box. So once you fill in the attendance form, you can claim the e-certifications of attendance. So tomorrow we will have another webinar, and then this will be the last day of our series webinar. So if you are interested, please join us tomorrow. And then very thank you, Dr. Loss, sharing. And then we
Thank you.
hope to see all of you again tomorrow. Okay, thank you,
Okay,
Dr.
thank you
Law.
everyone. Thank you. Bye.